Hello friends, Rahul Jha welcomes you. Today we are going to talk on topic cloud seeding. What is cloud seeding? Cloud seeding is a weather modification technique where substances like silver iodide, potassium iodide or dry ice are dispersed into the atmosphere to encourage precipitation within clouds. The idea is to enhance rainfall or snowfall in areas experiencing drought or to mitigate the impact of hail in certain region. These substances act as nuclei around which water droplets can condense and freeze, thus increasing the likelihood of precipitation. Cloud seeding is a topic of ongoing research and debate regarding its effectiveness and potential environmental impacts. What is science and process behind this? Cloud seeding works on the principle of nucleation, which is the process by which tiny particles act as nuclei around which water vapor can condense and form droplets. In natural clouds, there are already numerous tiny particles such as dust, pollen, and salt crystals that serve as nuclei for water droplets to form around. Cloud seeding augments this process by introducing additional particles into the atmosphere, thereby increasing the number of nuclei available for water vapor to condense onto. The most common substance used for cloud seeding are silver iodide, potassium iodide, and dry ice, solid carbon dioxide. These substances have similar crystalline structures to ice and can induce the formation of ice crystals within supercooled water droplets in clouds, which can then grow and eventually fall as precipitation. The process typically involves dispersing the seeding agent into the atmosphere using aircraft, ground based generators, or rockets. These particles are released into clouds where they mix the existing cloud particles. As water vapor condenses onto these particles, it forms droplets which may then grow large enough to fall as precipitation. However, the success of cloud seeding depends on various factors such as cloud type, temperature, humidity, and wind pattern. Not all clouds are suitable for seeding, and even under favorable conditions, the effectiveness of cloud seeding in producing significant precipitation remains a subject of debate and ongoing research. How it is achieved and ways to achieve it. So, cloud seeding can be achieved through various methods, each with its own advantages and limitations. Some common methods include aircraft seeding. Aircraft are equipped with seeding equipment such as flares or dispensers, which releases the seeding agent into the atmosphere. Pilots typically target specific clouds identified as suitable for seeding based on weather conditions and cloud characteristics. Ground based seeding. Ground based generators are strategically placed in areas where cloud seeding is desired. These generators release seeding agent into air either continuously or on demand using mechanisms such as burners or sprayers. Ground based seeding is often used in mountainous regions or areas with complex terrain. Rocket seeding. Can be used to deliver seeding agent directly into the clouds. These methods is particularly effective for targeting specific cloud formation or for reaching clouds at higher altitudes that may be inaccessible to aircraft or ground-based generators. Hygroscopic seeding. Hygroscopic seedings involve dispersing substances that absorb moisture, such as salt particles, into the atmosphere. These particles attract water vapor, promoting the formation of cloud droplets and potentially enhancing precipitation. Seeding. Supercooled seeding involves dispersing seeding agents that facilitate the formation of ice crystals within supercooled water droplets in clouds. Silver iodide and then dry ice are commonly used for this purpose as they have similar crystalline structure to ice and can induce ice formation at temperatures slightly below freezing. Each method has its own set of advantages and challenges, and the choice of methods depend on the factors such as target area, cloud type, weather conditions, and resources available. Regardless of method used, careful monitoring and coordination are essential to ensure effective and responsible cloud seeding operations. Which countries have used this? Cloud seeding has been conducted in various countries around the world for decades, primarily for the purpose of increasing precipitation, reducing the impact of droughts, and mitigating the effect of hailstorms. Some of the countries known to have employed cloud seeding include United States. Cloud seeding has been used in several states across the US, particularly in the western and central region, to enhance precipitation and snowpack in mountainous areas, as well as to reduce the impact of hail or crops. China. China has one of the largest and most extensive cloud seeding programs in the world. Cloud seeding is used extensively in China to increase rainfall, particularly in and semi-arid regions, as well as to reduce pollution by inducing precipitation to remove particulate matter from the atmosphere. Australia. Cloud seeding has been employed in Australia primarily in regions prone to drought to augment rainfall and water supplies. Russia. Cloud seeding has been conducted in Russia to increase precipitation and snowfall, particularly in the regions with water scarcity or where snowpack is important for water resource. United Arab Emirates. The UAE has invested in cloud seeding technology to enhance rainfall in arid regions and to mitigate the effects of drought. Cloud seeding has been used in Thailand to increase rainfall during the dry season and to alleviate water shortages. These are just few examples, and cloud seeding has been implemented in various other countries as well, often as part of government sponsored programs or research initiatives aimed at weather modification and water resource management. What are benefits and drawbacks of this? Cloud seeding offers potential benefits for certain regions and applications, but it also comes with drawbacks and considerations. Here are some of the benefits and drawbacks associated with cloud seeding. Benefits: increased precipitation. Cloud seeding can potentially increase precipitation in targeted areas, which can be beneficial for agriculture, water supplies, and ecosystem health. Drought mitigation. In regions experiencing drought, cloud seeding may be helpful in alleviating water shortages by stimulating rainfall and replenishing water resources. Hail suppression. Cloud seeding can be used to reduce the size of hailstorm in thunderstorms, thereby mitigate damage to crops, property, and infrastructure. Snowpack enhancement. Cloud seeding in mountainous regions can help increase snowfall and snowpacks, which is important for water supply, hydroelectric power generation, and winter sports industry. Air quality improvement. Cloud seeding can help remove pollutants from the atmosphere by inducing precipitation that washes out particulate matter and other contaminants. Drawbacks: effectiveness uncertainty. The effectiveness of cloud seeding can vary depending on factors such as cloud type, temperature, humidity, and wind patterns. There is still uncertainty around the extent to which cloud seeding can reliably produce significant increase in precipitation. Environmental impacts. Cloud seeding may have environmental impacts, including potential changes to local weather patterns, ecosystems, and water resources. The release of seeding agent into atmosphere and alteration of natural precipitation processes raise concerns about ecological disruption. Ethical and legal consideration. Cloud seeding raises ethical and legal questioning regarding ownership of water resources, potential conflicts between different stakeholders, and the responsibility for unintended consequences resulting from weather modification activities. Cost. Cloud seeding programs can be costly to implement and maintains, requiring investment in equipment, research, monitoring, and personnel. The cost effectiveness of cloud seeding compared to alternative water management strategies is often a subject of debate. Regulatory challenge. Cloud seeding may be subject to regulatory oversight and approval processes, particularly concerning environmental impact assessments, water rights, and international agreements on weather modification. Overall, while cloud seeding holds promise as a tool for weather modification and water resources management, careful consideration of its potential benefit, drawbacks, and ethical implications is necessary before widespread implementation. Continued research and monitoring are essential to better understand the effectiveness and impacts of cloud seeding and to ensure responsible use of this technology. What is impact of this on environment? The impact of cloud seeding on environment is a subject of ongoing research and debate. While cloud seeding is intended to modify weather patterns and enhance participation, it can also have various environmental effects, both positive and negative. Here are some potential impacts of cloud seeding on environment. Positive impact. Increased precipitation. Cloud seedings can potentially increase rainfall or snowfall in targeted areas, which can help replenish water resource, support agriculture, and restore ecosystems. Drought elevation. In regions experiencing drought, cloud seeding may be help alleviate water shortages by stimulating precipitation and improving water availability for human consumption, irrigation, and wildlife habitat. Hail suppression. Cloud seeding can be used to reduce size of hailstorm or thunderstorm, thereby mitigating damages to crops, property, and infrastructure. Air quality improvement. Cloud seeding can help remove pollutants from the atmosphere by inducing precipitation that washes out particulate matters and other contaminants, leading to improved air quality. Negative impacts. Ecological disruption. Cloud seeding may disrupt natural precipitation patterns and ecosystem, potentially affecting plant and animal population, habitats, and biodiversity. Water resource allocation. Cloud seeding may raise issues related to water resource allocation and management, as increased precipitation in one area could affect water availability downstream or in neighboring regions. Chemical pollution. The release of seeding agent into the atmosphere, such as silver iodide or other chemicals, raises concern about chemical pollutants, pollution, and its potential effect on air quality, soil, water, and ecosystems. Climate feedback. Cloud seeding may have unintended climate feedbacks as changes in precipitation patterns could influence regional climate systems and feedback loops, potentially leading to long-term environmental changes. Regulatory challenge. Cloud seeding activities may face regulatory challenges related to environmental and impact assessment, water rights, pollution control, and compliance with international agreement on weather modification. Overall, the environmental impact of cloud seeding depends on various factors, including the scale and intensity of seeding activities, the specific techniques and material used, local weather conditions, and ecosystem characteristics. Continued research, monitoring, and careful consideration of potential environment consequences are essential to ensure responsible use of cloud seeding technology. Thank you.